All right, good evening. So welcome back to Pre-Calculus. So this is going to start our chapter 5, trigonometric identities. And let me say a couple of things about this before we start. First off, this is the least worst option we could find. So I'm sorry about that. I'm not going to say it's the best option. This was the least worst one. A lot of them were multiple choice, and it doesn't really help you do anything. I'm going to walk through these with paper pencil or digital and pencil, or digital and pen rather, and then we'll show you what's going on with this. I am not going to promise that these are all going to be 100% correct because they are going to have us justify each step, and I won't always be able to guess the right step that they want us to justify. So there is a little bit of guess and check and prayer that goes in with, I hope I picked the right one that they were thinking of. Okay. So if that's happening to you, realize two things. One, you're not alone. And two, when I quiz you on these things, that this is created by a human being and not a computer. So if I see your steps here and it seems reasonable, then I'm just going to go ahead and say, yeah, that's what I want you to do. Okay. Other things. These are not equations, all right? These are proofs. These are your intro to proof type things. If you remember from geometry, this is what you're doing. Okay, you're going to start with trigonometric equation. Okay, and you're going to go down to a certain spot and you're going to prove what you're going to prove. Okay, so you're saying trig equation, or trigonometric identity expression, I'll say. Okay, we'll change that to expression. And you're going to do things to this expression like add 1, add 0 and multiply by 1. Use various different ways of expressing trig functions to get down to what you want. These are not equations, okay? You're not allowed to set them equal and then solve. Okay, so there is one thing you can do, and sometimes you're going to get stuck. You're going to go down to a spot, and you're like, I don't know what to do. And then you're going to go to the starting spot on this side, and you're going to work yourself up. And you're going to say, hey, wait a minute, these are the same. You are not going to say, hey, look, these are the same. You're going to work yourself down. You're going to go ahead and flip this one upside down or flip this one upside down, and then pretend that you got the right answer. Okay, so whatever you're going to do here, you're going to take this part, you're going to put this under the line here, and you're going to continue working until you got what you're supposed to get over here. Okay, so you're not going to treat these equations. There's not going to be a both sides. There's going to be a add 0, multiply by 1. Those are your options. Okay, so I want you to be really careful about that. Don't set them equal to each other and then solve. If you do, I will mark you wrong. That's not what you're allowed to do with this one. Okay, even if it looks like an equation, if it says verify the identity, it's not an equation. It might look like one, but it is not an equation. It's a proof. That's what we're trying to do here. Okay, so let me just start off. And again, this is an infuriating chapter because they want to make you justify everything that you're going to do. And sometimes that gets a little tedious. Okay, so first off, I can appreciate that. And secondly, that's pretty much how this works. So I should probably link the book Trig or Treat right underneath this, because this book, this is in our library, has tons and tons and tons of trigonometric identities that you can practice on. So here we have the tangent of x divided by secant of x, okay, times sine x. Okay, so what's this going to do for us? We're going to say, well, usually your best bet for solving any of these things is to change everything into sines and cosines and hope for the best. Okay? Sometimes there's like more advanced things to work with, but one of the techniques, one of the strategies you can use, like turn everything into sines and cosines and then hope that everything works out. So we're going to say that tangent is sine x over cosine x. Okay, secant is really 1 over cosine x, isn't it? Times sine x, and we're going to multiply these together. It would say cosine times 1 over cosine. That's going to be 1. So at this point, we have sine x over this sine x. So this is going to equal 1. Okay, so we're just going to say this is equal to 1. And I'm hoping that this is the answer that they wanted. Okay, so it should be a number or single trigonometric function. We'll check. Hooray, and we can continue. Okay, so that's just the way these things are going to work out. Let's try the next one and see what we end up with. Okay, so this is, okay, so we have cotangent x times cosine x, okay, times sine x, and then plus sine squared x. Is that all of it? It looks like it's all of it. Use algebra or trigonometric identities, and your answer should either be a single trig identity, single trig function, or a number. What's cotangent? Cotangent is cosine x divided by sine x. We have times a cosine x, we have times a sine x, plus sine squared x. The sine x's cancel, okay, because one's on the top, one's in the denominator. We have cosine x times cosine x, that's cosine squared x, plus sine squared x. Right, there's a very well-known trigonometric identity. Sine squared plus cosine squared is equal to 1. This is one of the Pythagorean identities, which you should remember for the rest of your life. Okay, so this is all equal to 1. So we'll give that as an answer and hope for the best. Okay, and then we'll continue. And this is pretty much what we're trying to do with all of these. Okay, we'll see if we can get one more in here. Simplify the expression, write the final form with no fractions. Okay, that's fair. So what do we have here? We have cosine x divided by cosecant x times cotangent x. Okay, so let's see what we're going to do here. We're going to say this is cosine x. What's cosecant? Cosecant is 1 over sine x, isn't it? And then what's cotangent? It's cosine x over sine x. So this is really cosine over sine. So this is really cosine x over sine squared x, sine times sine. Okay, and then we have to go ahead and simplify this compound fraction. So we have sine squared x over cosine x, top and bottom, sine squared x over cosine x, and then we're just going to say, hey, wait a minute, this is sine squared x over cosine squared x. That could also be tangent squared x. Okay, so that's what we're going to write down, and we're going to hope for the best on that one. So we'll write, where is my tangent? I want tangent squared x. Remember, they always have to have an argument. So if you just, at the end, if you're taking a quiz and you just write down tangent squared, I will mark you wrong. Okay, so will most other trig teachers. That's not just me, right? And we'll go ahead and check. It didn't like that at all. Try again. What did I mess up? This is why I don't like doing ones like this. It's over cosecant, which is 1 over sine x times, this is cosine x over sine x. So this is cosine x over sine squared x, sine squared x, cosine x, sine squared x over cosine x is cancel. Ah, there it is. So those cancel, boom, 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 equals sine squared x. Okay, let's change our mind on this one and say that we have sine squared. Okay, will we check? I'm just going to go ahead and keep it like this. That way, yes, I did lead you astray off the beaten path, and I hope bandits don't get you. Okay, But that's what we do for these. But we're going to do it correctly next time. Okay, so thank you for tuning in, and I will try to finish these guys with a little bit better accuracy, and we'll see how far we can get. Okay, thank you.